Okay, here are our notes for 11.3b. We'll start off with just doing a little bit of review. Just writing an explicit rule for the nth term of the geometric sequence. The fact that it tells us it's a geometric sequence means we are multiplying to get to our next term. And if we look, the pattern is to multiply by 4, multiply by 4, multiply by 4, meaning our common ratio is 4. And in order to write an explicit rule for a geometric sequence, we need the common ratio, and we need the first term, which in this case is 6. Because if we remember, a sub n is equal to a1 times that common ratio to the n minus 1, meaning our explicit rule is a sub n equals 6 times 4 to the n minus 1. All right, given two terms of a sequence, just kind of giving ourselves a visual. A1, A2, we know that that term is 28. And we know A5 is negative 1,792. Since we know it's geometric, that means we need to multiply by r, multiply by r, multiply by r to get to those next terms. Meaning to get from the second term to the fifth term, we would multiply by that common ratio 3 times, or that 28 times r cubed to get us negative 1,792. Solving for r, divide by 28, divide by 28, end up getting r cubed is equal to negative 64. Taking the cube root, we get a common ratio of negative 4. Now, since we have the second term, it is pretty easy just to work backwards. Instead of to get to the next term, you get multiplied by r. To get to a previous term, we're going to divide by that common ratio, so divide by negative 4, and we get a first term of negative 7. So our first term is negative 7. And again, in order to write an explicit rule, we need the first term, common ratio, which we now have. So a sub n is equal to negative 7 times negative 4 to the n minus 1. Okay, so 11.3b, what we're going to do this time around is find the sum of a finite geometric series, meaning that this series will end and has a given number of terms. Well, formula we're going to use s sub n is equal to a1 times 1 minus r to the n over 1 minus r. Again, s sub n is just telling us the sum through a specific number of terms. So if I was to say s sub 10, that's saying finding the sum of the first 10 terms. We'll write that down. So, find the sum of the series. Again, we are just going to use our formula. And again, if we look here, this is summation notation saying we're finding the sum of the first term through the ninth term. So we are finding s sub 9. And again, in the summation notation, there is our rule, meaning a1 times r to the n minus 1. They use I in this case, so our first term is 2. Our common ratio is negative 3. And again, if we look at our formula, it's the s sub 9. So 9 is replacing n, so our first term, which in this case is 2. So 2 times 1 minus r to the n, so negative 3. And our n is 9 since we're going through the ninth term, over 1 minus that common ratio again. And that there, it's just a matter of plugging it into the calculator, which you'll end up getting 9,842. And when I plug this into the calculator, I always take it step by step. So the first thing I would do is 1 minus that negative 3 to the ninth. Let's actually just write through this here. So when I go and plug this in, what I would do first is 1 minus -3 to the 9th. And again, that -3 needs to be in that parentheses, divided by 1 minus -4, which would be just 4. And then we're going to multiply that by 2. So just take it step by step. Makes things a little bit easier to get that 9,842. Moving on to the next one, we are finding the sum from the first term through the sixth term, so S sub 6. And again, it's the first term, which in this case is 5, times 1 minus the ratio, so 1/2, which I'm just going to write as 0.5 to the n, which in this case is 6, over 1 minus 0.5. Again, go ahead, plug that into your calculator, take it step by step, and let's walk through that. So we got 1 minus 0.5 to the 6th. I would hit enter at that point, divided by 1 minus 0.5, which would just be 0.5, and then multiply that by 5. Get 9.84375. So, big thing with finding the sum of a finite geometric series is just being able to know the formula and then plug in the proper parts. Plugging in your first term into the first term, plugging in your n to n, plugging in your ratio into the common ratio. Okay, so find the sum of the first 10 terms. Right there is telling us to find S sub 10. But typically, in the last two, we were given the rule. Now we're not given the rule. So what's going to help is if we're going to go and find that rule. And if it's geometric, it means we're multiplying times 4, times 4, times 4, and we have the first term. So the explicit rule is going to be 2 times 4 to the n minus 1. So S sub 10, we have our first term, which in this case is 2, times 1 minus our ratio, which is 4, to the 10, because we're taking it to the n power. Here's our n, over 1 minus 4. Go ahead, plug that in. We're going to get 699,050. So really, in this case, we didn't have to find the explicit rule. It never hurts. Okay, so find n such that S sub n is equal to 682. So again, S sub n is equal to a1 times 1 minus r to the n over 1 minus r. Now we are given, in this case, S sub n. I know this. I also know my first term. I know my ratio. I don't know n, though. So we're just going to plug in what we know. We know S sub n is 682. We know that the first term is 2. We know that our common ratio is 4. So in this case, all we need to do is solve for n. So what I'm going to do first is I'm going to take care of that 2, divide both sides by 2. So I'll get 341 is equal to 1 minus 4 to the n divided by -3. So then multiply by -3, multiply by -3. So we get -1,023 is equal to 1 minus 4 to the n. Add 1. Subtract 1. Subtract 1. We get -1,024 is equal to -4 to the n. Divide by that negative, and we'll get 1,024 equals 4 to the n. We have an exponential equation, if you have not noticed. So remember, inverses of exponential. our logarithm, so we're going to rewrite. So log base 4 of 1024 is equal to n, which again, you'll have a calculator, or 4 to what power is 1024, which is 5. So again, what this answer is saying is if I added the first 5 terms of that series, the total will be 682. So if you wanted to find times 4, you just have to add that next term. Those 5 numbers would add up to be 682. Just one more example of each type of that. Find the sum of the first 8 terms. So just finding that common ratio. How do I get from 1 to 8? Multiply by 8. So s sub 8 is equal to the first term, which is 1, times 1 minus common ratio of 8 to the 8th power over 1 minus 8. Plug that into your calculator. We're end up getting 2,396,745. Again, when you go plug that in, make sure to take it part by part. Again, given a specific sum, we got s sub n is equal to a1 times 1 minus r to the n over 1 minus r. I know the sum is that, so I'm going to take that, plug it in. 37,449 is equal to a1, which is 1, times 1 minus 8. We don't know n anymore, over 1 minus 8. So I'm going to say 37,449 is equal to 1 minus 8 to the n over negative 7. Multiply both sides by negative 7 to get rid of that. We are going to get negative 262,143 is equal to 1 minus 8 to the n. Subtract another 1. Subtract 1. Negative 262,144 equals negative 8 to the n. Okay, divide both sides by negative 1. Both are positive then. Again, exponential. Rewrite. Log base 8 of 262,144 equals n. Plug it into your calculator. You get n is equal to 6. Meaning, if you added the first 6 terms of that series, it would add up to be 37,449. There are your notes for 11.3b, geometric series. Make sure you go into Chapter 11 homework, 11.3 assignment. There are your problems.